Number 4, a couple hints I've got to answer part A. You definitely want to make sure that you look at the sign of delta H. Then the rest of them, B, C, and D, are all asking you to relate the amount of heat absorbed by this reaction with the amount of chemical being used. Now, you might think to yourself, well, if we look at this first one, calculate the amount of heat transferred when 40 grams of CH3OH is decomposed. Well, why isn't the answer just 90.7 kilojoules? And the reason is because it will be 90.7 kilojoules if we have used exactly 1 mole of CH3OH. But we aren't. We're using 40 grams, and I suspect that that's quite a bit less than 1 mole. So this is where we're going to need an energy conversion factor. The number of moles of CH3OH equals 90.7 kilojoules. And since our balanced equation has 1 mole of CH3OH in it, it's going to be 1 mole equals 90.7 kilojoules. And that's what we're going to need to use as a conversion factor in our unit conversion. So that's how we get from moles to kilojoules. And the way we get to moles, I'm assuming you'll be able to figure out how to get from the 40 grams to moles. So it's a couple-step process. Now, as you're doing the others, I want you to pay attention to your energy conversion factor. This is not always going to be 1 mole. Notice in the second one, they want you to do hydrogen, and so it's not going to be 1 mole there. My last tip for you is on D. If you look at D, they're trying to pull a fast one on you. How many kilojoules of heat are released? When 15 grams of CO reacts with H2, those are sounding an awful lot like reactants. CO is reacted with H2 to form CH3OH. So you notice it's not the reaction we're doing at the top, but it is the exact reverse of that. So take that into account when you're writing your energy conversion factor. The sign will change on the kilojoules.